All right, welcome back. You ready for a quick workout for your brain? Today, we're going to navigate a mental obstacle course, one designed to push the very limits of our own logic. So let's just dive right in.
Okay, to kick things off, a really simple question for you. When does a pile of sand stop being a pile? No, seriously, think about it. If you take away just one grain of sand, it's still a pile, right? Of course it is. But what happens if you just keep doing that?
So that little puzzle, that's our first big obstacle. It's a real heap of trouble. This is a paradox of vagueness, and it turns out philosophers have been wrestling with this one for millennia. Why? Because it goes right after the fuzzy, imprecise nature of the words we use every single day. Yeah, this thing has a name. It's called the Sorites paradox, and it's a classic logic trap. You start with something that seems totally obviously true, you use perfectly good reasoning, and somehow you end up with a conclusion that is just completely wrong. The idea that removing one little grain of sand doesn't change anything, that seems true. But the conclusion it leads to, well, that feels obviously false. So let's walk down this slippery slope together. Okay, first step, 10,000 grains of sand. That's a heap. We all agree? Step 2. If it's a heap, taking one grain away still leaves a heap. Okay, sounds reasonable. But if you buy that, then you have to accept that 9,999 grains is also a heap. And if you keep applying that same logic, you slide all the way down to this absurd conclusion. One single grain of sand is a heap. It just goes to show you what happens when you try to apply razor-sharp logic to a fuzzy word like heap. All right, ready for the next obstacle? We're going to shift gears here a little bit. We're moving from the vagueness of our language to the paralysis that can be caused by pure cold reason. This is the trap of the perfect choice. So I want you to just picture this for a second. You are faced with two options, and they are perfectly, absolutely equal in every single way. What do? How does a perfectly logical mind even handle a perfect tie? Well, there's a famous thought experiment that captures this exact problem. It's called Buridan's ass. This story goes like this. A donkey is equally hungry and equally thirsty. And it's placed exactly, and I mean exactly, in the middle of a stack of hay and a pail of water. Now, because the donkey is a perfectly rational creature and there is absolutely no reason to pick one over the other, it can't decide. It just stays there, frozen, and eventually dies of both hunger and thirst. And you can see here the problem is just perfectly symmetrical. It's a complete deadlock. You've got choice A, the hay, choice B, the water. The need is equal. The distance is identical. There is literally no rational reason to prefer one. So from a purely logical point of view, the only possible outcome is indecision, a complete shutdown. And look, don't just write this off as some silly donkey story. The philosopher Baruch Spinoza took this idea incredibly seriously. He totally bought into the premise, even writing that a man in this exact same situation would die of hunger and thirst. It's a pretty stark example of how pure logic, when you take it to its absolute extreme, can lead to a total failure to act. Okay, time to tackle our next challenge. We're leaving the world of pure philosophy and jumping right into the world of data and statistics, where, believe me, our thinking can get trapped in some equally weird ways, especially when we put too much trust in averages. And this brings us to something really sneaky called Simpson's paradox. This is what happens when you see a trend in different groups of data, but the second you combine those groups, the trend either vanishes or it completely reverses. Let's look at a famous real-world example. Okay, check this out. It's 1973. UC Berkeley gets sued for gender bias. Why? Because their own data showed that 44% of men who applied to grad school got in, but only 35% of women did. Now, just looking at this data, the conclusion seems obvious, right? It looks like a slam dunk case of discrimination. But then, watch this. The moment they broke the data down by department, the story completely flips. Look at Department A. Women had an 82% admission rate compared to 62% for men. In fact, in 4 of the 6 biggest departments you see here, women actually had a higher rate of admission. So what on earth is going on here? Well, it all comes down to what statisticians call a lurking variable. The investigation found that women were more likely to apply to the super competitive departments, like English, which had really low admission rates for everybody. Men, on the other hand, tended to apply to less competitive departments, like engineering, which just happened to have higher admission rates across the board. The bias wasn't in the admissions process. It was a ghost created by the data itself when you ignored the context. And that's a huge warning to always question those top-line numbers, because the real story is almost always hiding one layer deeper. Okay, for our final obstacle, we're pulling out the big guns. We're diving into one of the most famous logic traps out there, a favorite of sci-fi fans and philosophers, the tangled, messy knot of causality and time travel. Let's just cut to the chase. You have a time machine. What's stopping you from going back in time and, well, doing something that would make it impossible for you to exist? The classic question is, what if you killed your own grandfather? And yep, you guessed it, this is the famous grandfather paradox. It's a thought experiment that basically puts the whole idea of backward causation on trial. You know, the idea that an effect can happen before its cause. If you go back in time and prevent your own birth, then how could you have ever existed to go back in time in the first place? You see, the logic just ties itself into this impossible knot, this vicious loop. Let's walk through it. 1. You exist, so you can travel to the past. 2. You do it. You prevent your own birth. 3. Well, that means you never existed. 4. But wait, if you never existed, you couldn't have traveled back to do anything. 5, which means your birth wasn't prevented. 6, which means you do exist and can travel to the past. And around and around and around we go, forever. It all boils down to this one central contradiction. The effect of your action, you not existing, would completely erase the very cause of that action, you traveling back in time. It's a total head-on collision between cause and effect. So we've navigated the whole mental obstacle course. We made it. But why does any of this matter? I mean, besides being kind of fun brain teasers, what's the point? Let's zoom out and take a view from the top. The way to think about it is that paradoxes are basically stress tests for our brains. The heap of sand stresses our vague language. The donkey stresses the limits of pure logic. The Berkeley data stresses how we interpret numbers. And the grandfather paradox? Well, that stresses our entire understanding of reality itself. Each one of them is designed to find a weak point in our mental armor. When you get right down to it, what all these logic traps are really doing is shining a huge spotlight on the fuzzy boundaries and hidden assumptions that we all carry around in our heads. They show us the exact breaking point where our mental models of the world just fall apart. But that leaves us with the ultimate question, doesn't it? We can cook these up in our minds all day long. But could a true logical contradiction, a real, actual paradox, ever happen in our physical universe? Well, believe it or not, some physicists have a pretty wild answer. It's called the Novikov self-consistency principle, and it basically says no. The universe itself forbids it. The principle argues that any event that would create a paradox simply has a probability of 0. In other words, sure, you could travel back in time, but the laws of physics themselves would conspire to make sure you fail to kill your grandfather, no matter what you did. The universe, it seems, just might be paradox-proof. Now that is something to think about.